Hello, I am Kiran Kumar from Nature of Physics. Today topic is simple pendulum concept, very useful. We are getting numericals from this simple pendulum. In the previous year also we got the question. So first concept and related problems. We have 4 problems I am going to explain, and previous video was, that is reference circle, 2 videos are there. Please watch full videos, you will get clarity about the concept, and please do like and subscribe our channel Nature of Physics. Yes, I'm going to start the derivation. Yes student, simple pendulum of length L and mass of the pendulum bob is small m, representing, and let S be the point of suspension. This is S is the point of suspension. So this is mean position and 2 extreme positions are representing. Okay, so derivation we can do with respect to one extreme position. Okay student, so now I am going to explain about the mean position. So at mean position, tension is acting T0 upward direction, weight mg is acting downward direction. Both are equal in magnitude, opposite in direction. No need to discuss about it. Now we are discussing about extreme position. So that extreme position, the pendulum is making an angle theta with respect to vertical. Okay, and similar angle theta, mg is acting downward direction, so that mg resolve into 2 component, mg cos theta and mg sin theta, mutually perpendicular to each other. So one thing, at extreme position mg resolve into 2 components. First component, that is mg cos theta, horizontal component is balanced by the tension in the string. So T is the tension in the string at extreme position, which is balanced by the mg cos theta, clearly given. And next, mg sin theta is the unbalanced force. This unbalanced force is called a restoring force, student. So that derivation is from the restoring force, Fr, which is equal to minus mg into sin theta. Okay, but Fr, which is equal to ma, so that here minus represent the opposite direction, minus represent opposite direction. Next, ma, which is equal to, from the Newton's second law, Fr is equal to ma, which is equal to mg into sin theta. So ma's get cancelled, a, which is equal to minus g into sin theta. Okay, for small angles, sin theta approximately equal to theta. Okay student, so that continuation a, which is equal to minus g into theta, I can write this is equation number 1. And then continuation derivation considering triangle. So the triangle is OSP, O mean position, S support, and P is the extreme position. From this triangle, sin theta, which is equal to, opposite is x, and hypotenuse is, length is remain same at mean position and also extreme position. So the value in which sin theta again approximately equal to theta, for the very small angle sin theta approximately equal to theta. So that replacing in the above equation, that is theta is equal to, we are getting x divided by L, and this is equation number 2, equation 2 in equation number 1. So that acceleration a, which is equal to minus g into theta value replaced by x by L. Okay, so that a, which is equal, rearranging the equation, minus g divided by L into x. From the simple harmonic motion, from simple harmonic motion, a, which is equal to minus omega square x, see there, minus omega square x. Balancing the both equations, acceleration is same, displacement is same, minus also, comparison is there. So that I can write omega square, which is equal to g divided by L. So that omega, which is equal to root over g by L, and omega value is 2 pi by t, which is equal to root over g divided by L, student. So that I can replace, rearranging the equation. So 2 pi root over L divided by G, which is equal to T. See, clearly cross multiplication I did. So time period I am getting time period T, which is equal to 2 pi root over L divided by G. This I can write as equation number 3. And then continuation, there is a relation. So first one is time period is directly proportional to the length of the pendulum, and second relation, that is T directly proportional to the root G. So we got the two relations. And next one we will have the seconds pendulum. So the pendulum whose time period is equal to 2 seconds is called seconds pendulum. So T, which is equal to 2 seconds, and length of the pendulum L is equal to 1 meter, or which is equal to 100 centimeter, is taken as for the seconds pendulum. Okay, and then continuation, there is a relation for this time period T, which is directly proportional to the L, and time period which is inversely proportional to the root G. Based on this, I am going to write delta T divided by T. Common relation is T directly proportional to the root L divided by root G. So error I am writing delta T divided by T, which is equal to 1 by 2 delta L divided by L plus 1 upon 2 delta G divided by G. Okay, yes, next I am going to write the percentage error, that is delta T by T into 100 percentage, which is equal to half into delta L by L into 100 percentage plus half into delta G divided by G into 100 percentage. This is one of the application with respect to error related. Start about the numericals of the simple pendulum. Okay, see there, one by one we will discuss now. So first one is, I am considering this is the T is the time period of oscillation of the simple pendulum of length is L, suspended from the roof of the vehicle, okay, and which is moving without friction down on the inclined plane. There is no friction, and the vehicle is moving downward direction with an acceleration A, considering A acceleration. Okay, so that alpha is the angle of inclination given there. This is represented alpha clearly there. Okay, and then continuation, next one, here also we can represent alpha. And here a relation time period is asking student. So time period basic equation, so T, which is equal to 2 pi root over L divided by G for the time period of the simple pendulum for the normal condition. But here the pendulum is suspended to the roof of the vehicle, and the vehicle is making an angle alpha along the inclined plane. Alpha is the angle of inclination, so that there is a change in the time period, so that I am going to find now. So that T, which is equal to 2 pi root over L divided by G dash, this is representing time is T dash. So this is the normal condition, and this is according to the question. Okay, so that here G dash I am going to find there. One thing you have to notice, mg is resolved into two component. One is the horizontal component is mg cos alpha, and second one is the mg sin alpha. So mg is always acting downward direction toward the center of the earth, so in which mg sin alpha is a vertical component of weight is balanced by the pseudo force. Pseudo force is a imaginary force which is acting opposite direction to the motion of the vehicle. So that pseudo force is balancing the mg sin alpha, so that here resultant acceleration, that is g cos alpha, student. So that is g dash, which is equal to g cos alpha, and T dash, which is equal to 2 pi root over L divided by G cos alpha is the answer for the given question. See, and then next numerical I'm going to explain, second numerical. So time period of a simple pendulum is t on the earth surface, so that on the earth t which is equal to 2 pi root over L divided by G. Okay, and its time period become xt when it is at a height h. So h is equal to r from surface of earth a time period is t dash which is equal to 2 pi root over L divided by G. Okay, but here length is, time period is affected. Okay, and here G value will be changed, that we can write as here G dash. Okay student, so that in the question x is equal to asking. So try to understand the situation. On the surface of the earth t is equal to pi root over L by G. So second condition, h is equal to r from the surface of the earth, so that time period will be changed, that is t dash is equal to pi root over L divided by G dash, because of acceleration due to gravity will be changed. So the basic formula for the acceleration due to gravity, G which is equal to Gm by r square, this is the relation between small g and capital G, is replaced in the above equation. Okay student, so that I can write t which is equal to 2 pi root over L divided by, okay, G value is Gm divided by r square. So t which is equal to 2 pi into r square root of cancel, root over L divided by Gm is there. Okay, and next one, second condition is there. For this, for second condition, G dash will be changed. Okay student, so arrow mark is representing like this, so that G dash which is equal to Gm divided by, so that it is at a height r given, that is equal to the radius of the earth. So I can write there, that is h plus r whole square, but h is equal to r given in the question, so that G dash is equal to Gm divided by r plus r whole square, that is G dash is equal to Gm by 2r square. Okay, so that t dash which is, this is I can write as equation number 1, 2 pi root over L divided by Gm into 2r square student. T dash which is equal to 2 pi 2r, r for 2r square root of get cancel, root over we are getting L divided by Gm. This is equation number 2. Student, in the question t dash is equal given xt student. Okay, so that here equation 2 divided by equation 1 writing, so that t dash is equal to xt divided by equation 1 is t student, which is equal to 2 pi cancel, and root over L by Gm also get cancel. I'm going to get there 2r divided by r student, rr also get cancel, tt also get cancel, so that x which is equal to is the answer for the given question. Okay student, so answer is 2. See, this is A option is correct. And then continuation, next I am going to explain the next question, that is, wait a second, see there, a simple pendulum doing simple harmonic motion. Yes student, a simple pendulum doing a small oscillation at a place r height above the surface of the earth has the time period t1 is equal to 4 seconds. Okay, time period is t1, it is on the surface of the earth at a height h is equal to r student. So and next one, it would be t2, it is at a height h which is equal to 2r given, so that time period relation is asking, so that I'm going to find the relation. Basic formula time t, which is equal to 2 pi root over L divided by G, and then 2 pi root over L divided by G value is Gm by R square. So that is relation between small g and capital G, that is G is equal to Gm by R square is replaced here, so that I am getting their time period t, which is equal to 2 pi. Okay, r square is get cancel, I got r is common, and root over L divided by Gm. In this equation, t directly proportional to r I got. Okay student, and based on this relation we are going to discuss this and see. Now continuation there, T1 directly proportional to the R plus R, because of one R is based on the radius of the earth, because of small r is equal to R plus H student, so that it is at a height H is equal to R given, but we have to consider with respect to center of mass of the earth, so that is R plus R, and T1 directly proportional to 2R is written as equation number 1. And second condition, T2 is directly proportional to the R is the radius of the earth plus height is equal to how much given according to the question, 2R is given, so that T2 is directly proportional to the 3R. This is equation number 2. And continuation, next I am going to replace equation 2 divided by equation 1, that is T2 divided by T1, which is equal to 3R divided by 2R. RR is get cancel. Now cross multiplication, we will get that 2T2, which is equal to 3T1 is the answer for the given question. See student, already written their option, there is no space. Okay, and then continuation, next problem is, this is the previous year question also from the simple pendulum. T0 is the time period of simple pendulum at a place if the length of the pendulum is reduces to 1 by 16 times its the initial length. Modified time period is asking student. So initial time period t, which is equal to 2 pi root over L divided by G. Next to time period final, t dash is equal to 2 pi root over L dash divided by G student, but L dash, which is equal to L divided by 16 is given in the question. So replaced in the above equation, this is equation number 1. So that t dash, which is equal to 2 pi root over, that is L divided by 16 into G. So that t dash, which is equal to 2 pi, okay, that is 4 square is 16 square root of get cancel, that is 4 into root over L by G. This is equation number 2. Equation 1 in equation 2 we will get t dash is equal to, okay, that is 2 pi, once again writing 2 pi root over L by G, that is representing t value, and 1 by 4. So t dash, which is equal to t divided by 4 is the answer for the question, but in the question T0 time period is given, so that I am also writing here T0. This is the answer for the given question, already written here option. Okay, please do like and subscribe our channel Nature of Physics.